We'll just take a few minutes and go over some of Appendix A, starting with Matlab in the textbook. This is a very useful overview of some of the basics. Again, if you've not used the software very much, we've already gone through what each window means, over some of the variables, how to import some files. Well, now we can actually start going over some more in detail aspects of Matlab. One thing that kind of left out of the first set of basics that we covered was that if you want to suppress the output of assigning a variable, see, it repeats and it can actually make the screen scroll rather quickly. So we want to make b equals 6, but we put a semicolon after. It doesn't repeat the value for you. This is very interesting whenever you start not interesting, but helpful when you start programming your own functions, because you can now hide what those variable assignments are doing. Whenever you start producing thousands, if not millions, of assignments per second, if you have to plot each one to the screen and update the screen, it really slows down your software. So if you're writing a script in Matlab, it's best to always incorporate a semicolon, not for the sake like Fortran or C++ where it's required for line division, but more or less so you can suppress the output and speed up the function tremendously. I kid you not, it makes your functions go a lot faster and you don't have to output every single line to the command window. So that is one thing that's most definitely useful. Some other functions that can demonstrate some of the inbuilt utility. I mean, you have exponential functions, any sort of exponential 5. You have, of course, log functions, both base 10, both base e. So in this case, like, it's different than Excel. So if you do log of some examples, do log of 1,000, that's actually log base e. To do log base 10, you actually have to say log 10 of whatever value you want to do. Obviously quite different results. Square root, exponent, ABS is absolute value, sine, and then sine D actually gives you the output in degrees. Matlab, as you might expect, is radian by default. Lots of inbuilt and common functions exist. Ceiling, floor, fix, round. There's many different type of specific functions you can reference. I'll show you some of that Matlab online help file whenever you get to plotting. Format, I've shown you how to change that in preferences, but you can hard code this in any sort of script files you might be making. You say format short, and then now, so if you want to say, for example, the book uses 290 divided by 7 as a short display. If we want to format the output as long and do the same calculation, obviously a very different output format. One thing I find kind of funny among the different options, this is page 513, 514 in your textbook. Format bank. It's like money. It automatically truncates to the right number of decimals and rounds accordingly. We've already discussed arrays and how to put things together, but just as a simple reminder, anything in a singular row can just be separated by a space. Things separated on another line need to be separated by a semicolon, and that's how you go about entering matrix data. If you want to incorporate numerical and text entries in the same matrix and do operations on those, you actually cannot do that as a simple array in Matlab. You have to go to a different type of construct. So in this case, let's move on forward to addressing arrays. So if we need to pull the bottom right component, if we want to pull the 5 out of the matrix A, we just do A2, 2, pull out the 5. If we want to do A1, 2, that references the first row right hand side, A2, 1, that's second row left hand side of 12. That's how you can do addressable locations in arrays when you're programming in Matlab. Makes it really easy to reference different spots. If you do want to incorporate text, you can do it as simple as that. Now you're actually saving a text value into a variable. If you want help in creating variables, I've shown you some of these before. You can use inbuilt functions like zeros, ones, and in this case, if you want to reference the identity function, it's not I, as you might expect. They got clever and called it I. Let's see here, that'd be 3. So that's how you reference the identity function in numeric form to source a new variable in that format. If you're curious about the size of a variable that's already stored, let's look at the size, in this case, of A, 2 by 2. Let's see the size of the answer that's stored. It's 1 by 2. So it's actually very, very useful in determining how big a data set might be. Really, the value up here in the right-hand side in the workspace shows you what the size of those variables are, but perhaps you want to make sure when you're looping through information, you want to assign a variable for the number of iterations you have to perform on an object, and that size can be very, very useful in that sense. We've already covered element by element. Just kind of going through Appendix A here, looking for things that I haven't covered already that can be found very useful for you. Sorting functions, summation functions, mean functions all exist and can just be referenced very quickly. Determinant functions, like if we want to find the determinant of matrix A, it's as challenging as that. And of course, Matlab has no problem doing 4 by 4, 20 by 20. It'll find the determinant of very, very large matrices without a problem. Let's look at some very basic plotting functions in Matlab. I've gone ahead and entered in two variables of the exact same length, x and y. It's just a set of notional data. So the most basic is if you just type plot x comma y. This could be for data you enter directly or data generated by a function, and that generates the ultra basic Matlab output. On page 527, your textbook goes into some simple modifiers that you can do to change the visual style of these lines. If you want to go to, for example, dashed lines, you would use the symbol for dashed representation, do the same plot. In fact, if I can pull this out down here, now you see that the lines are dashed. If you wanted to go back and change, instead of lines, you want to look at points with pluses. There you go. Now that's representing all your data cloud as plus type points. Of course, different data has different types of representation. And this rabbit hole goes very, very, very deep in Matlab. A couple places I want to reference you to are the 2D line plot Matlab help files. Really, if you just Google any inbuilt Matlab function, they have wonderful online support files. You can access most of these through Matlab's help files in the software, but not only does it immediately give you the syntax as well as some of the line specifications and additional inputs these functions have, it goes through a whole description of the function, gives you multiple examples of what you can do with these functions. It really, really helps you learn how to get the data representation you want. This is the easiest, simplest Matlab plotting function. Again, there's everything in your textbook and more as far as marker styles, colors, line styles, etc. But I always want to encourage you to check the very bottom of the list, because now you actually see different functions. The hold function is very useful if you want to hold a plot open to plot multiple sets of data on one window. The legend, of course, displays a legend. Do log plots to change things to logarithmic axes. This is where a lot of that extra functionality gets built in. In fact, now you get to plot 3 dimensions. You have surface plots, contour plots. There's so many to go into, as indicated by the Matlab plot gallery, that to try to cover even some small portion of these in a rote description at one time would be a bit misguided. We will use the appropriate plot at the appropriate time for the example problem of interest during this class. You can do something with like wind direction and magnitude to show historical trends. You, of course, can do 3D scatter plots. These references are great because you should be able to just view the source of each one of these. It shows you how to set up that Matlab plot. Showing you the legends, the data styles, everything you would need to reproduce that. Let's go to something that's a bit more complex. Images. Yeah, you can do images in Matlab. You can do image processing. Actually, that's much more common in Matlab than you might first think. Let's take a look at which ones looks neat. Subplots. That can be very useful. Let's view the source of how to display different subplots. And then that's everything you need to do. You can copy it straight out of the window and use that as a basis for representing your own data in Matlab in terms of plots. Subplot is also something else you would use. This should also, actually they didn't have to use the hold function on here because they're doing one plot per window. But you can now create more or less a tiled grid of plots. So you see they start doing subplot 2x2 tiling, and this will be they're creating the 1-3 plot. This is subplot 2, again 2x2 tiling. This is subplot 2, 2x2 tiling. This is subplot 4. So this one occupies 1 and 3. That was the definition of subplot 2, subplot 4, and you notice that right after that subplot declaration, they go straight into the different types of plots shown. You establish a title, X labels, Y labels, do everything you need. There's really no better resource than figuring out how to plot data beautifully in MATLAB than this plot gallery. Okay, for the last part of our introduction to MATLAB, we're going to go over scripts, functions, anonymous functions, and sub-functions, how to use those to make MATLAB do your bidding. Let's go here to the main screen, clear off my mess, and of course you can use just basic input mathematics, but really at that point MATLAB's just a very expensive calculator. The real point of using this software, if I can just press Control-N for new, is to make M files or scripts or functions, whichever path you want to take with this. I use the keyboard shortcut, which obviously is terrible for a video. You can also just go to new script up there, and that creates an untitled file. Again, keep in mind and be cognizant of what current folder you're working in. I've just opened up MATLAB again for the day, so the current folder is way wrong. I'd have to set this appropriately. But in this case, you can write a script. You can say, instead of having to type everything into the command window directly time and time again, you can do operations here. A equals 5, and then B equals 3. You can do A plus B. And then if you press F5, it saves that file. I'll just throw it on the desktop for now. Untitled, fine. And it will run it. But in the process of running it, figured out, oh wait, I'm not working in the folder where this file is saved. Do you want to change? Yes, thank you, MATLAB, I will. And you can see it just regurgitates everything out of Untitled 2. That's called a script file. It's not really doing anything massively logical. I do not believe you can do loops in script files. You can't really do for statements. You might be able to do if statements, but it's really just like recording a macro of things you're typing in, which can be very, very useful if you want to make sure you don't make mistakes, if you don't want to have to use it as a direct calculator. It can be handy. It's like a little batch file. But it's very, very elementary use of MATLAB. These saved files, these M files, of which if I can show you, yeah, it's an actual file sitting here on the desktop. So you can save it, transfer it, do whatever you want. If you're wondering about how MATLAB can run scripts and functions without ever having to compile, it's actually doing it live. You don't have to go through that compilation step because it's basically compiling as it goes. It is looking at script syntax and script error, and I'm sure as you write complex scripts you'll find plenty of errors, but it does that compilation live as you're going through the software. Okay, the next thing to introduce would be a function. So, well, you just call it function. Let's make something simple. Cube me. So the purpose of this function is going to be to cube whatever input we give it. So we'll give it an input x, and then of course we need to say end. And MATLAB is nice enough to give us these expansion buttons, so you can actually collapse and expand functions however long they may be. Allows you to close things out. Now I've intentionally made a mistake here that won't become evident for a couple minutes, but the core of the function here might just be able to take your input, which we've defined as x, and we'll say that's the new value of x. To feed this out, we would actually say, we would assign it to the variable, to the functional name. Cube me equals x. Oops. So if we run this, it says we have a problem. Makes sense. We have to save because we gave it no input argument. So when I say run it, I just press F5 on the keyboard. That runs the script you're working inside of. But now that it's a function, we need to actually have an input argument. So cube me x, and this still won't work. Well, I should put a number in there for a reason that should be evident. Undefined function or variable cube me. Whenever you start running a function in MATLAB, it looks for a file called cube me. The primary function name should be shared in the file name. So this is called untitled2.m, not cubeme.m. Spaces aren't allowed. Other syntax isn't allowed in the file name. So let's fix that. I'm just going to rename this file cubeme.m and just open it up back in Matlab. Should be good to go now. Let's try that same command, and magically it can find it. So what you see happening is that the input command was cubeme parentheses 3. It looks through the active directory, which there it is, cubeme.m. And now it is, it goes through and does x equals x cubed, which that's the intermediate calculation, 27, and cubeme there in the bottom, that's the output reading 27. So that is the basic part of a function. Of course, you can put whatever you want here in the middle. But just one input, one output doesn't make for a good function, so let's make this a bit more interesting. X and Y, and then we can have two outputs, A and B. That is the proper syntax, unless I've made a mistake, hopefully not, for a multi-input, multi-output type function. You can do 18 inputs, you can do 14 outputs, whatever you want to do. Very, very large. You can actually have array data being sent as an input and array data being sent as an output into a single variable. You can have a lot of data flow into and out of functions. So let's make this a bit more streamlined. Let's just assign it directly to the output, except now instead of cubeme, we want to assign the outputs A, we assign the outputs B. Sure, I'm just making something up to demonstrate the point. So now we should save that again. Notice that the asterisk next to the file name, if we make a change here, let's in fact mute those intermediate calculations. There's an asterisk saying that, oh, you haven't saved this file. As soon as I say Control S for save, it goes away, and we can actually run this with F5, but it'll give us a mistake because we didn't give it any input arguments. So let's go back, just using the arrow keys, and go through our command history. I'll just give that value of 3 and 2. And then the output for cubeme just says 27. What happened to our multi-output? Well, you have to be ready to receive the multi-output is basically what it's saying. Let's call this out A, out B equals that. Now we can actually save the two different variables coming out of the function. If you only run the functional name by itself, like we did in the previous command, it saves the first number it gets as the answer from the function. If you actually are prepared to receive multiple outputs from a function, I mean, you should know how many it's going to generate. You're the one writing these functions, or at least you're hopefully reading the help files for the functions that are built in. You can actually receive both and save them in a variable name of your choosing. So that's pretty handy. Okay, the next type of function that is rather, it's a special case, useful. It's called an anonymous function. You can define these in the command window, you can define these in a script, or you can define these in a function. And it's really for having MATLAB execute a simple calculation conveniently for you a bunch of times. If you know you're going to be using the same algebraic formula 80 times in a script you're writing or something, you might as well make it an anonymous function to make it very easy. So the example given, let's just call it squareme equals, you start using this at, which is called a handle. The variable, the only one we're going to be concerned with is x, and the function is x squared, so that should work. It defines it as at parentheses x, and then the functional value is x squared. So now anytime we say squareme, give it a value, it does it. So that is an anonymous function. You actually see it listed over here in the variable definition window, telling you what that function is going to do. Of course, this is a very, very simple algorithm. It's just x squared, but you could put something much more complicated in there. That just makes it a nice syntax to allow you to call a little short subroutine. They are meant to be single line functions, and it's not a big deal. Let's show you one thing back in our functional definition file, cubeme. Let's make another function in the same file. Something very, very simple. Okay, simple with input t. Put end, and of course I really like that because it makes where you can collapse things. You don't technically have to put an end if you only have one function in a file, but it's just a cleanliness type topic. So let's just say t equals 2 times t, whatever function you want to put in the middle here. I'm just wanting to demonstrate the behavior and the calling of functions. So if we save this file, and we go up here and we want to call the function simple and give it a value of 5, we would expect the output to be 10. Can't find it. Undefined function simple for the input arguments. Double, it's a double precision number that we fed it. It can't find that function. Well, is it because of the name? Yes. The name should match the first function in the list. So if we take this function simple t and we actually assign it an output, simple equals 2 times t, and then here we'll be feeding y plus x into function simple, which nothing can actually be simple. You'll see that this, unexpectedly for me, produced an error. There's too many output arguments. Error in cube_me, line 5. Notice it is actually looking inside the cube_me function and finding simple. It's just creating an error in output. So I bothered this for a few minutes. Found that if you actually specify an output, it's much happier. You can't really just assign it back to the functional name like the working example I showed you previously did. Let's make sure this is saved. Yep, call the same function again, and now it works. You notice we fed it 3 and 2 for values of x and y. So for the calculation of the b output, it added 2 and 3 together, 5, and it went down here to the subfunction, multiplied them by 2, fed that back into this first function to assign it to the output b, and out it came as 10. So the lesson of this is you can have subfunctions in a functional file, but you can't call them from outside that file. Only this first function inside the file can call subfunctions within it. So don't think you can define all 8 of the functions you need to run a program inside the same file and call them willy-nilly externally. Not going to work. These are only accessible within the file unless you go through, I'm sure there's some more complex path of direction and headers so you can actually reference sub-functions inside of the workspace. But by default, it's only this first function that can be called from the command window. So that's the basics of scripts, functions, anonymous functions, and sub-functions, and that should be enough to get you going. Appendix A in our textbook does continue into a little bit of programming, but that's just far too in-depth to go right now. You'll see many programming examples in the pieces of software I hand out in the class. You'll see programming examples in basically intermixed throughout the rest of the course. So you'll learn it little bit by little bit, new features. This is meant to be a numerics course, not a programming class. So for right now, as an introduction, we'll stop right here just with that basic functional structure and how to set these things up in Matlab.